So I'm just demonstrating what happens with the half-life of a 0 order and then also of a second order. And these half-lives do represent the amount of time it takes for something to deplete by half. But the problem is that a 0 order and a second order reaction, the slope of the line and everything, it doesn't match up correctly so that it's a consistent half-life. So what I'm saying is this. For a 0 order reaction, if we take the concentration and we divided it by a K value, and that unit on that K value matches a 0 order K unit, you still have a time. So it's like, 31.9 seconds is how long it takes for this concentration to change by half. But then it's kind of like you reset the original concentration at the end of that half-life for the next one. So it's like this. In this case, so here's our original. And so if we are trying to figure out, so like where the line should fall is that top right point of the rectangle if we have a consistent. And so right now, what our half-life is like that number. So if you keep that distance in mind, the next half-life, it's all the way down there. So it's a lot farther. It's a lot longer of time. Like it's past 60. Whereas this one is the first one. It was like 25. It should have fallen at 50, but it doesn't. It falls all the way over like past 60. So the time of the half-life is different. So that's what happens with the 0 order. And the same kind of weirdness happens with the second order also. So right here's our K value, and I've had to put in the units. These are the units for a second order K value. But we're still starting with that same initial kind of concentration. And you get that kind of a number with the seconds again. Now, this isn't plotting that same data point, but this is showing you where the problem comes in with this one. So if we are starting at like some amount, and actually I'm going to move it up just so that it starts at a number. And then we are trying to get it over to this one's half-life. So it's like that distance for the first half-life. And then we're trying to get it up to the 2. It's all the way over there, and it's that distance for the second half-life. So I don't know if you can kind of see. So that's like 45 seconds for the second time it's in half, and this is like, I don't know, like 21, something like that. So you can see that the half-life, again, it just doesn't match out perfectly. If we go back to that first order half-life, just so you can get a sense for it, though, this is what should be going on, is that initially you've got the 2. So our first half-life falls at the 0.1. And so when you go at that time, so there's 20 seconds. When you go to the next half, it's that 40-second mark. So 20 more seconds has gone by. Trying to make that one work perfectly. But that's what's supposed to happen in those reactions. You're not supposed to have that varied time.